I've been able to call people by name and have people talk, okay? But anyhow, okay, so at least one person got, I said got this right and didn't. So just to review quickly, we're just solving this equation. And it's something everybody who's done the homework has been able to do without any trouble. Okay, we distribute through here, we get 2x minus 6 equals 5x. Add 6 to both sides. So I kind of like to circle it when I do that, just to make sure I keep track of it. Okay. And then negative 6 and 6 is 0, so we get this. And then we subtract the 5x from both sides. And we get negative 3x equals 6, x equals negative 2. Also, don't skip the substitution of the checks. Okay, you get 2 times negative 2 minus 3 equals 5 times negative 2 when you substitute the negative 2 for x. Is that a true statement? Well, you get 2 times negative 5 equals negative 10. Negative 10 equals negative 10. You got it. So if you did get it wrong, it was for some trivial reason, because I saw everybody doing the right steps. But when you go back and check, you find that it didn't work. So fix it. Okay. I want to ask everybody, check your masks. Sometimes they slide down. You do have to keep the mask up. Okay. Okay, so let's move on. You've got the 3 times 2x plus 4 equals 5 times 3x minus 7. Multiplying through, we have 6x plus 12 equals 15x minus 35. Now, the same steps that we use over here, except we have to use a distributive law on both sides. And then we get an equation that we still have to pretty much do the same things on. Choosing to put the x's on the left side. Now you can choose to put them on the right side, that's fine. Okay, but traditionally we'll use them on the left side. That's the way I usually do it. We got the 6x plus 12 and we subtract 15x. I just chose to do the x's first. Okay, you can do the numbers first. You can add negative 12 to both sides. Okay. As far as that goes, you could add 35 to both sides, but that would be putting your numbers on the left. So that's not the way I choose to do it, but that's still okay. All right. And that gives us 6x. Well, gives us negative 9x plus 12 equals negative 35. And then we subtract 12 from both sides. Like 12 zeros, you get negative 9x equals negative 57. So that now we do negative 9x over negative 9 equals negative 57 over negative 9. Okay. And at this stage, you want to be careful because you've been adding things and subtracting things from both sides just out of habit without really thinking about it. You see me make mistakes like this. You might want to add a 9 to both sides and think that's going to get rid of the negative 9, and it's not going to do it, right? You have to divide. You undo a multiplication by division. Okay. Anyhow, that's going to give you x, because negative 9 over negative 9 is 1. And negative over negative is a positive, so it's 57 over 9. That actually reduces to 19 over 3. Because both these are multiples of 3, so we divide the numerator and the denominator both by 3. Reduce the fraction. I believe everybody's okay with doing that. Now, if I did it right, that's a solution. I'm not going to plug it back in. I do that in my head, but it's probably screwed up, so I'm not going to bother. If it's right, it's right. If it's wrong, it's wrong. You can check it as well as I can. If I made a mistake, well, debug it for me, okay? No, we're not actually going to do that right now. Okay, this problem. I want to really try to convince you that you don't want to work with fractions. I see that I have denominators 3, 2, and 6. Okay. What's the common denominator? Well, if you did the thing in fractions where you're adding fractions, you're used to finding a common denominator. You just find a common denominator, which is 6 in this case. Made it easy for you. And you know, problems aren't going to in the book aren't going to be that hard. You might use numbers a little less, a little harder to figure things out with, but it won't be bad. You multiply everything by 6. And officially, you do this: 6 times the whole left-hand side. You know what? That's what I wanted to do. I did it first because I wanted to stress it, but that was not. Instead of writing it out, I'm going to first, you want to distribute, okay? Yeah. Hang on. Whoa. Okay. Mistake here. 35 and 12 is obviously 47, not 37. So correction there. Now it doesn't reduce, just 47. It's prime. Okay. Nothing divided. Okay. Okay. A fashion statement. I had to get the bands up a little higher. Actually, they were too close to my hearing aids, and they were irritating me. Okay. So again, start this one over. I'm going to multiply both sides by 6. I can see that already, but I don't want to do it in the first step because I want to go ahead and do the distributive law. We have a place where we need that to get everything into single terms. Okay. Then multiply both sides by 6. You might be tempted to do 2/3 minus 3/2. And you might do like I did working with somebody there. You can see that as a 2/3 and say, well, it's a negative 1/6. That's a 1/6. Okay, well, yeah, you can make mistakes like that. I can make mistakes like that. Okay. So you keep these as separate terms because they're going to combine really easily after you multiply everything by 6. So you get 6 times 2/3 x, and you can write that as, since that's a fraction, write that as 6/1, so you can see what the numerators and denominators. Okay, so I've just written down the multiplication by 6 in front of everything, because that's what the distributive law does, especially if you write it out completely, like I didn't. You got to multiply this side by 6 as well. I just wrote that down wrong. I actually did it down here. Okay. So nothing wrong with this step. That step should have indicated the multiplication by 6. That's kind of important. important enough. We'll circle that 6. Now we understand why we did 6, how we got the 6. It's the common denominator for the whole equation. Yeah. Having multiplied everything by 6, well, we go ahead and simplify these. 6 times 2 is 12. 1 times 3 is 3. 12 divided by 3 is 4. And I assume you can do this. Okay. If you have trouble with it, there's an assignment I think coming up pretty soon. We do multiplication by fractions, but that's basic stuff. I think most of you are okay with it. Okay, well, 6 times 3 is 18. Divide that by 2, you get negative 9x. 6 times 12 is 72. This here is just going to give you 5x plus 54. Now, none of that is difficult. Okay? And at this stage, you don't have to do fractions again to the end. This becomes a really easy equation. And you get negative 5x minus 72 equals 5x plus 54. Okay? And then you solve that. You're going to end up with negative 10x here. You're going to end up with 126 here. Now I'm skipping steps. I'm putting 3 dots there, indicating I want to see those steps when you do it. Okay? But we know those steps. They're saying the steps we've used before. I don't want to take class time to do it. And then we can reduce this. This would be negative 63 over 5. And you can fill in the details and, you know, I did it in my head, so maybe there's a mistake, but that's, once we're here, we're home free. If we know how to do all this, and I think everybody's okay doing all this. Okay, and well, you see that we can add 21 to both sides, right? I don't have a lot of room. Well, so adding 21 to both sides without filling in the stuff, we get this, right? Then we got to subtract 5, 6x from both sides, right? So that's going to give us negative 5, 6x minus 5, 6x equals 21, right? Well, at this stage, you're going to have to do negative 5, 6 minus 5, 6. So at this stage, what you really need to understand to do this is factoring, which we haven't talked about. But factoring is just distributive law backwards. You will agree that this is the same as x times negative 5, 6 minus 5, 6, right? If you multiply this out, this is exactly what you get. Then you add these fractions. Okay? They have the common denominator, so you get x times negative 10, 6 equals 21. Okay. Or, and I'll write it out this way, negative 10, 6x, because we usually want the number in front. Okay. So that x equals, well, again, I'm out of word straight. Let's just see. Okay. We then multiply by -6/10. And we get this. And you're right. Congratulations, you worked it through. Because 6 times 21 is 126, right? So we get -126, or 126 over -10. Okay, or -126 over 10. So this times this is just one, -6/10 times -10/6 is -60 over +60 over 60, right? 60 over 60 is 1, so we get that's written small, I hope it'll show up on the video. Okay, we get x is -20, 126 over 10. So I'm impressed. Okay, and I thought it might be so, because everything I saw looked really good. So as an exercise in doing it the hard way and learning a lot about fractions and making sure you're good at fractions, that was really good. And you, as you said, you see how this makes it a lot easier. Okay, so you've got it both ways. Okay, very good, very good. Okay, well, the point I want to make, I'm still recording. The point I want to make is that there's nothing in these problems that you couldn't do if you were following the rules carefully enough, based on what we did in class last time. And if I had done in class last time, if I'd have done a problem like this in class, it would have taken a lot of time and you'd have had trouble understanding it until you encounter it. And I believe, and if I didn't, it's on me, I believe I've told you, you need to multiply by common denominator. Okay? If I haven't, then I apologize. Okay? But now that we've emphasized it, I really want you to understand that strategy, okay? It reduces your probability of an error significantly. Again, very impressive. You were able to work that through using the fractions. I really like that. Okay. Okay, one student simplified it somewhat by adding these fractions, well, subtracting in this case. They got the -5/6 here, okay? And that's okay. If that shortens it for you, use whatever combination of steps gives you the most reliable solution, okay? Now, if you're in a hurry, you also want to worry about the quickest solutions, okay? Just had the big programming project I mentioned. It's not really a programming project, it's a text identification project. But I'm always balancing speed versus reliability. Okay, I'm taking a little chance here. Okay, and if there's an error here, it's really going to cost me later, but I don't think I'll make many errors here, and I'll pay that cost because I'll get done 6 hours soon. Okay, and then it takes me 12 hours to find all the errors. But or if I judged it right, maybe it only takes me an hour to fix those errors, and an hour to identify them. Okay, so it's always a balance when you're solving an equation. Balance reliability and accuracy versus speed. Since you're not timed on tests in this class, no quizzes you are, there's a limit to how long you spend on quiz. So, speed has some advantages. But if I see really good steps, then I'm going to grade it fairly leniently anyway. Now, if you don't get to an important problem, then I can't really give you credit for having solved that problem. But, make my judgments. And the bottom line is I'm trying to prepare for tests, okay? Just a midterm test and a final exam. And that really determines how you do in this course. Whether you pass it or not, and everybody seems to be well in their way to at least passing. And then whether you get the recommendation to just skip the MDE 61 and go directly into pre-calculus. It looks like many of you, if you keep working the way you are, hopefully everybody can get that recommendation, okay? And as I said, I make that recommendation based on what I think gives you the best chance for success. Okay. Okay, we focus. Looks like maybe we've left out, but we put the lighthouse up here just. Okay, first of all, the absolute value of a number, and hopefully you know this, but the absolute value, just by example, the absolute value of -6 is 6. Okay, absolute value of a number is just how big it is, not whether it's positive or negative. Okay. I've got to assume you understand that about absolute value, or you will, because it's pretty easy. The first few problems are pretty easy, okay? That you can use it. So I want to go on to this. Well, what if the absolute value of x is 12? Okay. Now, we'll discuss this a little bit. Pause. Okay, this is an equation. Absolute value of x equals 12. You know that there are two values of x that make that true. -12 would make that true, and x equals 12 would make that true, right? So I swear I wrote a negative on that. I thought negative. I obviously didn't write it. Oh man. Oh, flip. I might as well give up and write it again. Okay. So x equals -12. Something in me is just resisting that negative sign, or x equals 12, right? So your solution set is a set consisting of -12 and 12. Okay? That makes sense? All right, well, how about this? Okay, now what can you tell me? Not about the solution to the equation, but about the value of x minus 7. Okay, so I asked what's the absolute value of x minus, or what's x minus 7, and I got some complicated answers, which is not unexpected because what's the rule here? You know, what's going on? Okay, but if the absolute value of something is 8, that something either has to be 8 or -8. Okay, so I know that that's one solution to this problem is a solution to the equation x minus 7 equals -8. Okay, this is one instance where this could be true, and the other instance is for x minus 7 equals 8. Now you're home free because you can certainly solve these equations. Okay, so add 7 to both sides. X equals -1 or x equals 15. And then check. put 15 in the equation. You get absolute value of 16 minus 7 equals 8. Absolute value of 8 equals 8. Yep, it's true. Okay. We can also put this in. Let me put some color here. Take the x minus 1 and plug it into the equation. And we get absolute value of negative 1 minus 7. I said 7 and I wrote it. I needed some weird combination of good sense and visual imagery. Okay. So we have negative 1 minus 7 equals 8. So the absolute value of negative 8 equals 8. And we know that to be true. Okay? That's a complete solution to the equation. The equations get more complicated. I'm not going to get too complicated because we have limited time. And I don't want to press the assignments too much. Okay? We have this. Well, this automatically splits into these two equations, both of which you know how to solve. Make sense? Nothing to it, as long as you remember to split into two equations. Now, it can get a little more complicated if the absolute value of one thing equals the absolute value of another. I'm going to have to let you look at the videos, okay? And see what you can do with those. Have something like this. Okay. Now, what you want to get it down to is absolute value of 2x minus 5 equals something, and then you can split the equation, right? Okay. Well, it's not hard to get down to this stage. We can subtract 6x from both sides, giving us I'm not writing down the step there, but again, I would expect you to write it down, right? Minus 6x and minus 6x, just keep reinforcing that. Then we divide by 3. Well, we get there almost immediately. Divide both sides by 3, we're going to get 3 minus 2x. Okay? So that I usually do the negative first. X minus 5 equals negative of the quantity 3 minus 2x. Or I'll have to write it down here. 2x minus 5 equals 3 minus 2x. As long as you keep yourself focused on the fact that you want that absolute value to equal something, then you're okay. 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 Well, that's absolute values. I wish we had a little more time to talk about it, but I don't think you're going to have too much trouble with it. Now, that doesn't mean there aren't problems you're going to have trouble with. It just means that the basics, if you know how to translate that, that's really what I want to see, okay? If you can't do the most complicated problem in the set or the most complicated 30% of the set. I'm not too worried about it because if you get the basics, you'll be able to do it next time, but we'll still talk about it, okay? Okay. So linear inequalities. Even easier. A little complication, except you gotta be careful if you multiply or divide by a negative number. So there's my trucks over there. Does that make sense? Everybody okay with that? Exactly the same steps in this case. Now, the case where we don't follow exactly the same steps, so we've got to be a little careful. Oh man, I didn't do any of that. Yeah, okay. Okay, if I want to graph y equals x squared, I'll make a table. Now, the table I like to use, and use extensively in my class, and I'm going to go ahead and use this table. Then I'll explain a little bit about why I use these values, okay? So, okay, if x is -2, then, well, let's discuss these values for a second. Okay, this could be the square of -2, right?
You want to be positive forward? Okay.
Oh, whoa.
Sorry. I'm the worst.
Okay, I'm gonna keep that in there, because you said something right, it can't possibly be embarrassing.
Oh, I don't.
Please, you laughed.
Might as well start over now.
Okay. I know. I hate doing these classes where we can't do this. Okay, but sometimes it leads to humor. Okay, so we square -2. What's that mean? That means -2 times -2. And what's -2 times -2? You said it, unfortunately, +4, right? Okay. Well, similarly, -1 squared is 1. -1/2 squared is 1/4. 1/2 times 1/2 is 1/4, right? And 2 negatives. 0 squared is 0. 1/2 squared is 1/4. 1 squared is 1. 2 squared is 4. So now we can make a graph. I like to start with graphs of what I call basic functions that go from -2 to +2. And we scale on that graph. I divide this interval in half. That's where 1 is, right? I divide the interval from here to here in half. That's -1. Then I divide this interval in half and I get 1/2. And over here, I get -1/2. And now my graph is reasonably well scaled. Okay, this interval is a little shorter than this one. That should be of equal length, but it's still going to give us a reasonable picture. Okay, then we need numbers from 0 to 4. Well, here's 4. Put 4 in the place we want. We probably don't want to put it down there. Okay, here's 2. Here's 1. Here's 3. And if we divide the interval from 0 to 1 in half, we get a half. If we divide the interval from 0 to a half in half, we get a fourth. Okay. Now try to review that if you don't see it immediately, and try to understand that, because I think it's a good way to understand how to scale a graph. Okay. In any case, now we plot the points. When x is -2, y is 4, right? Now where is x -2? Well, all the points above and below -2 on the x-axis have an x coordinate of -2. Everyone understand this? Okay. And then the y coordinate has to be 4. Well, every point on a horizontal line through the y equals 4 point on the axis has y coordinate 4. So there's a point. Okay. Now, one thing we don't do is we don't graph using a graphing calculator. Now, if you construct a graph by hand and then go to the graphing calculator, see if you did it right, that's okay. But I just stay away from the blank thing. You need to learn to graph. Once you know how to graph, you know how to use a graphing calculator, if you don't know. Okay? Okay, anyhow, we plot the rest of these points. -1, 1, -1/2, 1/4. So that's, way down here. 0, 0, 1/2, 1/4, 1, 1, and 2, 4. Right there are our points. And then we can connect these points, not with straight lines like somebody might have taught you at some point in your education, because a lot of people want to do that. But that doesn't represent this function. The curve does. Okay. So the points give you an indication of where the curve ought to be. Okay. So you're going to have an introduction to graphing. If there are problems that give you a lot of trouble, and you've made a reasonable effort, as I said, I can always say, well, made a reasonable effort, complete the assignment, the ones on the half credit page, and I could give you full credit. But if you just don't have time to get them all done, well, you still have a half credit page to fall back on, but don't get behind if you can help it. Because we're moving into the intermediate algebra now, okay? And if you understand everything we've done, it won't be that hard, but it's going to be new to some of it.